Okay, students. So, in today's lecture, we'll discuss few questions based on Coulomb's law. Right? So, in the last lecture, we had seen about discussed about Coulomb's law, and also we had derived the formula for Coulomb's law in vector form. Okay. So now let us see some application of Coulomb's law. That is, we'll solve the sums on Coulomb's law. Okay. We'll start with easy question. Suppose there are the first one. There are two charges, 2 microcoulomb and 5 microcoulomb, separated by distance r. Okay. Find the ratio of force acting on each other. Okay. Basically, there are two charges. One is of 2 microcoulomb and another is of 5 microcoulomb. Solution. Let us say this has 2 microcoulomb, 5 microcoulomb. Separation is R. Okay. Since both are positively charged, then they will repel each other. That means force on 5 microcoulomb because of 2 will be in this direction, and force on 2 because of 5 will be in opposite direction. Okay. So force on 5 microcoulomb because of 2 will be given by K equal to by R square. Let us say this has 1 and this has 2. Okay, this has 1. So force on 1 because of 2, that will be K into 2 into 5 into 10 raised to minus 12 upon R square. Similarly, force on 2 because of 1 will be K into 5 into 2 into 10 raised to minus 12 divided by R square. Since R is unknown, so we have been told to calculate the ratio. So the ratio of force on 2 because of 1 and force on 1 because of 2 will be minus 1:1. Clear? Minus 1:1. Since the direction is opposite, so we'll place a negative sign. If you have been told to just calculate the ratio of the magnitude, then it will be 1:1. Got it, student? It's very easy. Force on 2 because of 1 is always equal to force on 1 because of 2. Done? Fine. Another one, see. Second one. Let us say there are two charges, Q and minus Q, separated by distance r. Okay. The force acting between them, is say F. Okay. Two charges, Q and minus Q, they are separated by distance R. The force between them is F. Now, if 25% charge is transferred from Q to minus Q, what will be the new force between them. This is your question. There are two charges, q and minus q. They are separated by any distance r. Okay, and the force between them is F. Now, if 25% charge is transferred from q to minus q, see, so what will be the new force for the same separation? Solution. This is q, this is minus q. The distance between them is r. So F will be equals to k q minus q by r square. Okay, so this is your force. Fine. Okay. Now, question says 25% charge is being transferred from say q to minus q, that is say from A to B. A to B. So new charge on A will be q minus 25% of 25% means 25 by 100. So that will be q minus q by 4. So this will be 3q by 4. So now charge on A will be 3q by 4. Here, see in the question it is given that 25% charge is being transferred from A to B. That is from q to minus q. Okay. So next, now the charge on B will be, okay, so charge on B fine. New charge on B minus q plus q by 4. Yes, because 25% of charge is being transferred from A to B. So 25% is 2500, so that is q by 4. So this will be minus 3q by 4. So the new force between them will be F dash is equals to k. Now this will be 3q by 4 into minus 3q by 4 upon r square. So this will be 9 by 16 kq minus q by r square. Okay, but what is kq minus q by r square? F. So finally your answer is 9f by 16. This was also asked in your JEE exam. Okay, done students? Okay students, so now the third one. See, two charges placed in air at a distance r exert a force F on each other. Okay, two charges placed in air exert a force F on each other. Now, the same force acts between the two charges, when placed at a distance r dash in a medium of dielectric constant K. Find r dash. Okay, see the question. Two charges are first placed in air at a distance r. They exert a force F on each other. Now, the same force acts between the two charges when placed at a distance r dash in a medium of dielectric constant K. See, we had seen in Coulomb's law that the force between two charges when placed in a medium gets decreased by factor k. Right? That means we had seen the formula Fm is equals to F upon k. Right? That means force between two charges when placed in vacuum and the force between two charges when placed in medium. So force between two charges when placed in medium decreases by factor k. Okay, see, solution. First, when two charges were in air at a distance r, the force will be k q1 q2 by r square, where k will be 1 by 4 pi epsilon naught q1 q2 by r square. Now, the same force acts between two charges when placed in medium. So, force between two charges when placed in a medium is given by 1 by 4 pi epsilon q1 q2 by r dash square. Okay, students, epsilon is the permittivity of any medium and epsilon naught is the permittivity of vacuum. Now, the question says find r dash such that the force between two charges in air and medium should remain same. That means this force is equal to this force. Now let us solve this question. So we'll compare the two equations and we'll find r dash. See. So F, according to the question, Fe equals to Fm. That is 1 by 4 pi epsilon naught q1 q2 divided by r square equals to 1 by 4 pi epsilon q1 q2 upon r dash square. q1 q2 4 pi gets cancelled. So epsilon will go over here. So it is epsilon by epsilon naught into 1 by r square equals to 1 by r dash square. What is epsilon by epsilon naught? K. So it is k upon r square equals to 1 by r dash square. Therefore, r dash will be r by 2. This will be the new distance where the force between two charges when placed in a medium will also remain the same. Clear, students? Done? Fine. The next one. Okay. Force acting between two charges of 2 millicoulomb and 4 millicoulomb at a distance r is F. If charge of minus 2 millicoulomb is added to both the charges, what will be the new force between them? Okay. This is quite simple. First, the force between two charges. One is of 2 millicoulomb, another is of 4 millicoulomb, separated by distance r is F. So F will be equals to K into 2 into 4 divided by r square. Now you are adding a charge of minus 2 millicoulomb to both the charges. That means you are adding a charge of minus 2 millicoulomb to plus 2 millicoulomb and plus 4. So the new charge will be 2 millicoulomb. You are adding minus 2 millicoulomb. So it will be 0 Q1 and Q2, 4 millicoulomb plus minus 2 millicoulomb, that is 2 millicoulomb. So one charge is 0 and another is of 2 millicoulomb. So the new force will be F dash is equals to K Q1, that is 0, 2 by R square. So the new force will be 0. Done? Okay, students. The next one. Okay, see, there are two identical spheres A, B. Okay, let the separation between them be R. Fine, A is having the charge of Q, B is also having the charge of Q. Both are identical and the separation between them is R. Okay, so let the force between them be F. So F will be equals to KQ square by R square. Now, a third sphere, identical but uncharged, third sphere C is first made in contact with A, then it is allowed to make a contact with B. See, understand the question very clearly. There are two spheres identical. I'll write the question. Two identical spheres A and B carrying a charge Q, separated by distance R. Clear? There are two identical spheres A and B carrying the charge Q and they are separated by distance R. A third sphere identical to A and B but uncharged is first allowed to make contact with A and then with B. Find the new force between A and B for given separation. See what the question says. There are two identical spheres A and B. They are carrying a charge Q separated by distance R. So the force between them will be KQ square by R square. Now third sphere, which is identical to both A and B, that is the third sphere C. Right? It is first allowed to make a contact with A and then it is allowed to make a contact with B. So you have to find the force between A and B then for a same separation. So, firstly, the force between A and B is given as KQ and Q2 by R square. Now, when C is made in contact with A, so the charge will be equally divided. So, A will have a charge Q by 2 and C will also have a charge Q by 2. By the process of conduction, charge will be equally divided. Clear? So now already when C is made in contact with A, charge on sphere C will be Q by 2 and charge on A will also be Q by 2. Clear? So now when C is made in contact with B, so charge on B will be Q plus Q by 2 because already B is having a charge Q and C is now having a charge Q by 2. So this will be equals to 3Q by 4. So now the force F dash will be k q by 2 3q by 4 divided by r square. So this will be 3kq square divided by 8r square. So that is 3f by 8. Got it, student? Got it? Clear? Okay, so now in the next lecture, we'll discuss about superposition principle. Thank you.